Hello everybody, I hope everybody's doing great today. We're going to talk today about a specific topic called the standard deviation. Now, to talk about standard deviation, I usually like to talk about, um, the best way that I can understand what standard deviation is basically the grouping or separation of a certain group of data, okay? So, for example, let's call it the grouping or separation of a set of data. Okay? Now, I'm going to explain this to you with a couple of pictures and a couple of images of charts that I've seen that I think are pretty interesting to look at. The first thing is that, for example, in this case, we of course have to take into consideration the average. The average of all of this is 100. But as you can see, the standard deviation for the red area is 10, which is smaller, which means that most of the data is located within these 10 values, basically. And in the case of the standard deviation for the blue area, is located within all of these values, which means that they have a much bigger separation for the grouping. Another way to look at it is by checking out this other chart that I'm going to show you. In this context, it tells us that, for example, 34% of all the data is here. The other 34% is here. That's almost 70%. 13% is in this area, 13% is in this area. And the closer you get to the outside of the bell curve, the less the amount of data is. Down here is 0.1% of the entire data. Over here is 0.1% and so forth and so on. So the closer you are to the center, the more concentration of data there is. Okay, so as you can see, the data in the center is grouped together. The data over here is pretty separated from each other. Okay, so the first thing that we're going to look at is the formula to calculate the standard deviation. Okay, now we're going to show you the formula in a very fancy way, and then we're going to interpret it in an easier way to understand. Okay, deviation. There we go. Now, the formula to calculate the standard deviation can be represented in many ways. Of course, if we group it together in the way that I'm going to show you right now, is probably the easiest way to look at, but not the easiest way to understand. Check this out. This is going to look super fancy. Okay, now the standard, I'm going to call it SD. The standard deviation is this beautiful formula that we have here. Now let's look at it in a different way. Let's look at it with an example. Okay, let's click on example right here. Here we go, example. Okay, and let's put this to heading number 3. There we go. Or no, heading number 2 I think looks a lot better. As you can see, I like working with these options from Word. Okay, we're going to calculate the standard deviation. Okay, deviation from grades. Yeah, from grades. Grades from 8 students. Now, the important thing that we need to consider just from the get-go is that we have a total of 8 students. Okay, we're going to put data that I've already calculated and put here so we can take into consideration, or we can look at. Now, this is the grades from students with a range from 0 to 10. Okay, we're going to go from 0 to 10. Let's say that we have a couple of students that are pretty bad, 2, 4, or it's probably bad teachers, I don't know, 4, 5, 5, 7, and then we have a student with a 9. That's a total of 8 values. Okay, the first thing we have to do is we must calculate the median, and we're going to put here also known as the average. Okay. Now, the values are going to be represented right here in this formula. Now, take into consideration that this I'm showing you is part of this big formula up here. This is a much easier representation of what we have. So we're going to grab all of the numbers. 2, 4, 4, 4, 5, 5, 7, and 9, and divide it by the amount of values. In this case, it's 8 values. And all of this equals 5. You can do your calculations on your own if you'd like. Okay, then we must calculate, continuing on applying the formula, the deviation, okay, taking into consideration the median. And each result is elevated to the square. Okay? Now, I've gone ahead and done this just so you can look at it. Now, the first thing, we're going to just talk about the value of 2. Now, it says, taking into consideration the median. Now, according to this formula, I have to take the value minus the median and elevate it to the square. The value minus the median elevated to the square. In this context, it's 2 minus the median, which is 5, and elevated to the square. So the first part of the formula is going to be 2 minus 5 elevated to the square, like this. Okay, what's that equal to? That is equal to minus 3 elevated to the square. And minus 3 elevated to the square equals 9, like this. Okay, now that's the first step of the formula. Now, as you can see here, we have to do it with every value. We have to do it with all of them, okay? So we're going to do it with the rest, and we're going to do it with 4, 4 again, 4 again, 5, 5 again, 7, and 9. Okay, I've gone ahead and done that beforehand, so check this out. So we have 4 minus 5 equals minus 1. That's to the square, that's 1. 1 again, then 5 minus 5 is 0, elevated to the square is 0. Then we go to the 7, 7 minus 5 is 2, elevated to the square is 4, and 9 minus 5 is 4, elevated to the square is 16, okay? Now after this, we have to calculate the variance. Okay, the variance is the median of these resulting values. Okay? So we're going to take all these values and calculate the median or the average again. Okay, and this is what we get. We get sigma elevated to the square. Now this is part of the formula. This is part of the formula. Again, sigma elevated to the square. Okay? Equals 9 plus 1 plus 1 plus 1 plus 0 plus 0 plus 4 plus 16, as you can see here, divided by 8. This result is 4, okay? So the variance is 4. So sigma to the square equals 4. Now we have to change the square over to the other side of the equal, which means that we're going to apply a square root. And finally, the result is that the standard deviation, okay, is equal to the square root of the variance, okay? And the formula looks like this. It's pretty simple, like this, okay? Sigma equals the square root of 4, which equals 2. So the standard deviation equals 2 in this context. Of course, let me get this back to the previous page. Yeah, there we go. So the standard deviation equals 2 for this data set. For this data set in specific, what we've done is calculated that equals 2. Okay? Now we're going to do something in Excel with a much bigger data set or set of values. Okay? So we're going to put a bunch of values here. Now we could do this randomly. We could move all the values that we want. In my case, what I'm going to do is I'm going to put a value, let's say 1.35. Why not? 1.35. Okay, and then we're going to add, just for the sake of the purpose, this doesn't have to be this way. This is just to show you how the standard deviation behaves in a chart. Okay? So in this context, we're going to add another 1.35. Why not? Okay, and we're going to do this all the way to 20 values. Okay, so this is a total of 20 values. It goes down to 21. That's a total of 20 values. Now, the first thing that we have to calculate, the first thing that we need is the average. We need to calculate the average. Now, there's two ways of doing this. One of them is by adding up all the numbers. We add up all the numbers like this. Okay, and we have a total, we're taking a total of 20 numbers. And then we're going to divide all of this by 20, okay? So we're going to divide it by 20 and we get a total of 14.175. Or we could just use the average formula. Average, like this, then select all the numbers and we should get exactly the same result. There we go, 14.175. That's perfect. Now the next thing that we have to calculate is the normal distribution, okay? How distributed all these values are. Okay, here we go, normal distribution. Okay, by calculating the normal distribution, we can apply a formula that is right here in Excel that's pretty cool and accessible. It's called norm.dist. Okay, now the normal distribution asks for a bunch of information. Okay, the first information that it asks, the x value that you can see here, is going to be our original value, which in this case is 1.35, our first value. Perfect. Then it says the mean. The mean is basically the average, which we have right here. Okay, then the next value is the standard deviation, which we do not have yet. Okay, so we don't have the standard deviation. All right, in this case, we're just gonna put a 0 right there. We'll come back to it in a moment. And then it says cumulative. It says true or false. In this case, we're just gonna use false just so we can move forward. Okay, and it's gonna give me a number right there. Yeah, it says no, I can't calculate it because you have a 0 in there. And I go like, oh, all right. If you have the value right there, so we have to have the standard deviation. Okay, we have to have the standard deviation. Now, to calculate the standard deviation, we're going to use a formula, and we're going to prove it a little bit later. We're going to use this formula called standard deviation P. Okay, standard deviation. Okay, standard deviation P. We have several standard deviation options here in Excel, but we're going to use one specific that says standard ST, which is standard ST. Then deviation, but we're not going to use that one. STDEV, no, we're not going to use that one. We're going to use P, okay? We're going to use P, which is this one, the last one. Okay, and then we're going to select all of these. No, not that one. We're going to select all of these numbers, all the way up to 21. Okay, and you need to be careful that you choose just the values. You cannot go and integrate the average in there. Okay, and the standard deviation for this is 7.78, etc. Okay, we have that value. So now we can include that value here in the 0. Okay, so let's include that value right there. And our normal distribution for the first value is that. Now, if we include all of this, we're going to see that it's going to be incorrect. And the reason it's incorrect is because we need to fix all these values. Okay, we cannot fix this value, but we must fix the value of the average and the value of the normal distribution. Okay, those values cannot move. All right, so now we can copy it all the way up to down here. Okay, and this is the normal distribution. Now, this is a pretty cool thing. As you can see, the normal distribution for the first one is the same one as the last one. And the normal distribution is a lot bigger in the center, which means that we will have a very interesting bell curve, right? Okay, now the next thing that we must calculate is the deviations. Yes. We must calculate the deviations, all right? The deviations are going to help us graph the bell curve, okay? The deviations, and they're also going to help us prove if we are correct or not. Now, in the case of the deviations, the formula that we must use is this one exactly, this one right here, okay? Right, the deviation, here we go. This is the deviation, so we're going to calculate it applying this formula, okay? So the deviation is going to be calculated by applying the value, which is this one right here, okay, minus what? Minus the median, okay? You're going to calculate it minus the median, all right? So we're going to go this one, minus the median, which is the average, okay? Right? There we go. And we're going to elevate everything to the square. So we're always going to get an affirmative number, okay? And we elevate it to the square by putting this little tilde right there and elevate it to the 2, to the second power or to the square. And that's our deviation right there. Now we're gonna pull it all the way down, and it's going to also be incorrect because we need to fix the value, okay? And if we keep going down, as you can see, it starts taking no value from here. We need to add the standard deviation for everything. Now, to add the standard deviation, we have to fix the first value. Okay, we have to fix the first value. We have to copy it all the way down, and there we go. As you can see, the first one and the last one are exactly the same. And then in the center, we have the lowest one, which is opposite to this one, which is the highest one. Okay, we're starting to see certain tendencies. Now, another thing that I want you to observe again is that I want you to look at the standard deviation, okay, and I want to prove that the standard deviation is correct. Okay, so let's put standard deviation, we're going to call it differently, okay? But now we are going to apply this formula directly. We're not going to apply anything that has to do with Excel. Okay, so let's see if this is correct. The first thing that we should do is we should add up all of the numbers, all of the deviations, because as you can see here, we are adding up all of the deviations. Okay, so we're going to add up all the deviations. We're going to go to sum, add up all the deviations like this. Okay, cool. 1,000, whatever. Then we're going to divide these by the amount of values, which is a total of 20. So we're going to divide this by 20, okay? And divide this by 20. There we go. And we get this value, and we're going to apply the square root. And if the square root is correct, we're going to get this value right here, okay? The same one. Okay, so we're going to put SQRT, square root. We're going to open parentheses, and we're going to close parentheses. Okay, and we got exactly the same number. Okay, which means that the way that we calculated all of this is correct. Okay, that's perfect. Now we're on the right track, okay? Now to do this, to calculate the chart title and to calculate the chart, we need to take all of these values right here, okay? Let's see if we can take them from the title. We're going to grab all of these values, the values and the normal distribution. The deviation we just used to calculate the standard deviation and to prove it, but these are the ones that we actually want to put in a chart. So we're going to put here insert, okay? And we're going to look at these, the ones that says scatter. Okay, scatter, and we're going to choose the center one with smooth lines. Okay, let's see what we get. There we go. We got a normal distribution with a perfect bell curve, which is exactly what we're looking for, because as you can see, the normal distribution that you see here, okay, or the well, we have to change the name of this. This is not the normal distribution. This is a standard deviation. There we go. Standard deviation, okay? As you can see, the curve that you have right here is exactly the same one, or it looks exactly like this one, which is what we were looking for. But the bell curve is behaving like this because all of these numbers are, you know, distributed in a very even way. Of course, if we grab these values and change them into something completely different, the bell curve is going to look completely different. Let's say that I put rand between, and I put something like between 1 to 5, okay? If we do that, then, and we put all these values differently, then the bell curve is probably going to look very differently in a very strange way. Then we cannot calculate the standard deviation because there's no real standard. So let's take it back to the way it was. And there we go. So that's how you calculate the standard deviation for a regular number of data set, okay? So make sure to let me know if you have any comments or questions. Oh, and one more thing that was important to take into consideration. Another reason why we cannot look at the data in the way that it looks proper like this is because they have to be in order. If the numbers are in order, then you will see something that is a lot easier to calculate, okay? And it looks a lot better, right? And then you have something that is closer to a curve. Okay, then the standard deviation is, so as you can see, the lower values have to be on the top and the higher values have to be all the way to the end. Okay, so let's leave it how it was, 1.35, and then we add this, we are going to add 1.35, and if we grab all of this stuff and copy it over here, we're going to see a curve that is perfectly straight. All right, so if you have any comments or questions, please drop me a comment right here in the video. Thank you so much.